For our global Apple final, our team of Evan, Grace, Lucas, and Christian decided to undertake a fascinating exploration of the global phenomenon that is Apple by taking apart an iPhone using an iFixit kit. By disassembling this ubiquitous device, we were able to explore the intricate components that make up an iPhone and delve into the complex supply chain that supports its production. As you can see in some of the overlaid video, we explored the inner workings of the iPhone and discovered an array of components ranging from the familiar battery and camera to more specialized parts like the logic board and haptic engine. By examining these components closely, we gained a deeper understanding of the engineering feats that have gone into creating this remarkable device and the global network of suppliers that have come together to make it possible. In the ensuing video, you'll learn more about our investigation of each of the parts and metals that make up our very iPhones. Furthermore, our investigation of the iPhone supply chain allowed us to explore the far-reaching economic, social, and environmental impacts of its production. You may find yourself asking questions about the working conditions of the factory workers who produce these devices or the environmental impact of the materials used to make them. And now let's get into each of the parts. So when looking at the iPhone's cameras, as I'm sure you're all aware, they're broken up into the front-facing camera and the back-facing camera, which projects outwardly. Both cameras are currently made with the True Depth feature and are actually not made out of sapphire like many people reported after there was a fiasco a couple years ago with manufacturing inside the United States. So the front-facing cameras on the iPhone have what is called a dot projector, which gives real-time depth data and visual info. The system consists of LEDs that can then project an irregular grid of over 30,000 infrared dots, which allows for photo depth to be produced in a matter of milliseconds. The system was first introduced in 2017 and is now the driving force between the portrait mode pictures and Face ID recognition that we have on our phones. Actually, Apple is able to outsource the supply of these iPhone components instead of producing them internally like many people believe. And some of their competitors are actually responsible for this production. So Samsung is the company that manufactures the OLED or OLED displays in the iPhone. And then in the future, LG Electronics is working on the prototype for these displays because they're actually responsible for the prototypes for foldable displays for future iPhones. Both Samsung and LG produce these displays in South Korean factories. And the maker of the iPhone camera system itself is Sony, which Tim Cook actually confirmed in December 2022. Sony's camera production facility is based in Kumamoto, Japan, and this partnership with Apple has lasted for over a decade. Now moving on to arguably the most important part of your iPhone's interior, the metal casings. Without these small metal casings, your iPhone would be unable to be pieced or held together. There's actually hundreds of these small metals inside your phone, unbeknownst to most users, as your iPhone is an incredibly complex piece of machinery with many metals and minerals that comprise your iPhone. So from a mass level, aluminum makes up 24% of the iPhone's mass, iron's at 14%, copper's at 6%, and gold also has a fair significance in the phone. Those are just four of the massive metals inside your phone. So now we'll just dig a little bit deeper into where each one comes from, manufactured, how it eventually gets to your phone. So aluminum is actually extracted from something called bauxite, which is a sedimentary rock with high aluminum content, which is typically found in Australia, Brazil, and India. This is considered a non-renewable resource since it cannot be replaced without going through recycling. The mining of bauxite also is known to cause significant environmental damage, including habitat loss and soil erosion in the countries where it's mined from. And there's also, concerns over greenhouse gas emissions during smelting and processing. So the use of recycled aluminum can reduce this negative environmental impact of mining bauxite. Switching over to iron. So iron is extracted from iron ore using a blast furnace. And this oxygen needs to be removed from the iron oxide through a reduction reaction. The two major producers of iron are Australia and Brazil, which each hold significant reserves of iron ore. Australia is actually responsible for half of the world's iron ore exports. Iron is also, like aluminum, a non-renewable source since it cannot be naturally reproduced, and is also known for having negative environmental impacts on the regions which it's extracted from, including landscape losses, atmospheric pollution from extraction, and then disposal of or slags. Now to talk about copper. Copper is extracted from oxide and sulfide ores, which sulfide ores accounting for 80% of global copper production. Chile is the world's leading copper producer, followed by Peru, and copper mining significantly and oftentimes permanent ecological impacts on local biodiversity, surface and groundwater, and land cover. Copper, like the others, is also a non-renewable source, so once the supply runs out, there will be no more left. And lastly, transitioning to gold, the majority of gold production actually comes to the United States in Nevada, where over 74% of gold is mined there. Gold is highly resistant to corrosion and an excellent conductor of electricity, so it's incredibly valuable in consumer electronics, specifically in the iPhone, but also in pretty much any other technological product that you use on a daily basis. Gold is also non-renewable, and like the others, also has some significant negative environmental impacts, such as causing soil erosion, contamination of surface water, and the formation of sinkholes.
Okay, so the parts I'm focusing on today are the main components on the logic board. The logic board is extremely complex, and even with this assembly guide that we followed, it was still very difficult to fully take out. There's over 30 chips within the entire iPhone, so I'm just going to focus on what I believe to be the most five important ones. That being Apple's A11 Bionic chip, the LTE transceiver, the Wi-Fi and Bluetooth module, the Taptic engine, and then finally the memory. Okay, so Apple's A11 chip is the main computer behind the phone, and it's just responsible for most processes on the phone, and just basically tries to make them as fast as possible. We weren't actually able to remove the black casing on the photo here on the right, but the chip would be directly underneath that. Apple manufactures these chips in Taiwan using that company, and that company gets their raw materials primarily from Japan, America, and China. And after doing extensive research into all these parts, it's pretty hard to track down the entire list of raw material suppliers to these different companies. So we're just gonna show the top 3 or 4 countries where they source their raw materials. Next, we have Qualcomm's LTE transceiver. This allows the iPhone to connect to cellular service. It's also the very first 5G transceiver ever made available to the market. It's kind of cool to know. It is unknown where Qualcomm manufactures this specific part because they don't actually disclose their factory locations. But based off the research and other factories, if it wants to be in supply chain, the Asian Pacific region is a solid guess. That being said, they do disclose the main areas where they get their raw materials. So namely Japan, Germany, and Sweden for Qualcomm. Next, we have Murata's Wi-Fi and Bluetooth module. Just pretty self-explanatory as to what it does. These are created by Murata Manufacturing Company, and they source most of their raw materials from the Philippines, Indonesia, Vietnam, and Malaysia. And then here we have another fully Apple-made device, which is the Taptic engine. The Taptic engine controls all user feedback via touch, so vibration, 3D touch, any haptic feedback. These are made by AAC Technologies in China, and they mainly get their raw materials from South Korea, China, obviously, and Japan. And then last but not least, we have Toshiba's 64 gigabyte flash memory. Yeah, so this is manufactured by Toshiba itself, and the materials are sourced from China, Australia, and South Korea. It's kind of interesting to see that only of the 5 main components, Apple has only created 2 of the 5, which is pretty crazy. Apple's supply chain is extremely complex, and it's just a pure feat of engineering to be able to fit, all these different chips and modules all from different companies into one sleek, like aluminum box. Each of the 5 parts were all manufactured from different factories, and of those factories, they all source their raw materials from over 15 different countries. So, yeah, just one part of the enormous supply chain.
So today I'm going to be talking a little bit about the iPhone XR display and screen, which includes the LCD display, the frame and the casing for the screen, which you can see in this picture from what we disassembled, and then the glass itself on the screen and on the back. So to start off, I'll talk a little bit about the iPhone 10 versus the 10R, which we took apart a 10R in our video. And so the iPhone 10 was the first iPhone to not have a home button and to instead have an edge-to-edge screen. It also had the first OLED screen. However, the model that we took apart, the 10R, does not. It has an LCD screen, although at the time it was the most advanced LCD on a smartphone. And another difference between the two of them is that the frame of the 10R is made of aluminum, whereas the frame of the 10 is steel. So the screen is a liquid retina display, which is a kind of screen that only Apple uses. It combines a retina screen with a liquid crystal display or an LCD. And so essentially a basic retina display is a screen with so many pixels packed so tightly next to each other that you can't see the individual pixels or any jagged lines on the screen even when you look really close. This screen itself builds upon a basic retina display by adding liquid crystal display to that. And so the result uses 10,000 LEDs in its pixelated display and combines the haptic effects and contrast ratios from the basic retina display to produce a higher level of pixels per inch. And there are many materials that go into an LCD screen in addition to the glass. This includes transparent glue, a touchpad, a polarizing filter, a matrix, a backlight, sensors, and the metal frame. And so the iPhone 10R screens were manufactured in Japan by Japan Display Inc., but unfortunately they do not disclose any of their suppliers for the raw materials or which of those parts they build themselves versus outsource to other people. The frame for the iPhone 10R is made of aluminum, as I mentioned before, and Apple lists the Fujian Nanping Aluminum Company and ChemQ Aluminum Products Limited Group as their main suppliers for the year that the iPhone 10R was released. But most of their aluminum is manufactured in China mainland by Apple in-house for these frame pieces. And it is interesting to note, however, that Apple recently started buying lab-made carbon-free aluminum from a company called ELYSIS, which is a joint venture between two other companies, and it's based in Canada. This is kind of to support their eco and green initiatives and sustainability for future products. However, the iPhone 10R predates this by a couple years. This was just signed into action this year, last year. But I just thought that was interesting to mention for aluminum in iPhone products in the future. So now to get into the glass that goes into the iPhone 10R, there's glass on the front screen and then also on the back of the phone. This is interesting because I believe the iPhone 10 was the first iPhone to have glass on the front and back before the back was more of a matte metal. And so this kind of made Apple's next leap into that, more smoother feel and sleeker look and everything, just to kind of continue that momentum for them. So the front screen on the iPhone 10R is protected by the Gorilla Glass 6, which is put over the LCD screen that we just talked about, and it's made by a company called Corning. The back glass is not specified what type of glass it is. Apple doesn't release that information, but what they will say is that it's just as strong and durable as the Gorilla Glass. However, I think it's important or kind of funny to note that in our video where we take apart the iPhone 10R, the one that we had, the back was actually super cracked and shattered and there were pieces of glass everywhere, and the front was totally fine. So I think that personally we've already put that theory to the test, and we kind of saw that maybe it's not as totally strong and durable, and that's why they're not really specifying what it is. Anyway, it's interesting. This Gorilla Glass is a really interesting thing because Steve Jobs actually called the CEO of Corning in 2007, right before the release of the first iPhone, and he asked him to make a new type of scratch-proof and shatter-proof glass for this first iPhone before its release. So that's how that came about. And fun fact, Corning's first glass factory was built in the 1950s, at first to create lenses for eyeglasses, and then they transitioned to LCD glass panels in the 1980s. It's also the company that developed the glass for the Edison bulb in 1879. Gorilla Glass itself is a type of aluminosilicate glass that's strengthened through a proprietary chemical process. Its main ingredient, like virtually all glass, is high purity silica sand, typically above 99.5% purity, so it's essentially silicon. The silica is then mixed with some combination of aluminum, sodium, and magnesium. The materials are all mixed and melted in a high-tech oven in what Corning refers to as a fusion draw process, so the glass forms and hardens without ever being touched by a human hand. But in order to achieve the gorilla level strength that gives it its name, it kind of undergoes an ion exchange process, and it's soaked in a sodium salt bath, and that allows the sodium ions in the glass to escape and be replaced by larger potassium ions. And then when the glass cools, the potassium ions are compressed much closer together, which creates that additional rigidity and scratch-proofness that Apple boasts about. Although we can't say for sure where Corning gets its raw materials from, because neither Corning nor Apple released that information, it's very likely that they get their silica from one of the leading suppliers in the industry. A few of these companies are mentioned here on the left side of the screen. And interestingly enough, a few of these leading suppliers operate right here in North Carolina, which actually has some of the highest purity silica in the world. And then Gorilla Glass is manufactured mainly in Corning's oldest glass factory in Harrodsburg, Kentucky. Although now, due to increased demand, they also manufacture in some of Corning's new factories in Asia. So it's very likely overall that the majority of the raw materials and the manufacturing of at least the glass on the screen of the iPhone XR can all be traced back to right here in the United States.
The outer shell of the iPhone, excluding the screen, is made up of predominantly refined aluminum. The raw materials extracted from aluminum mines, with the two main suppliers being Rio Tinto Limited in Australia and Alcoa Corp here in the United States. The process of aluminum mining begins with clearing out vegetation to create open pit mines where bauxite, a reddish-brown ore, is extracted. Once the bauxite is mined, it is crushed and mixed with caustic soda at a refining facility. This mixture is heated in a digester, which dissolves the alumina, a white powdered substance, from the bauxite. The resulting solution is then filtered to remove impurities. The alumina is then smelted to produce aluminum. This process produces molten aluminum, which is then cast into blocks or ingots for further processing. However, Apple has made a shift towards using low-carbon aluminum in the last year because of its commitment to reducing its environmental impact. They plan to use the world's first commercial purity low-carbon aluminum from Elysis, which is a joint venture between Apple and Rio Tinto based out of Quebec. Traditional aluminum smelting processes are energy intensive and produce significant amounts of harmful emissions, giving them a considerable carbon footprint. Low-carbon aluminum, on the other hand, is produced using a single process that emits oxygen instead of carbon dioxide, resulting in a significant reduction in greenhouse gas emissions. The raw aluminum is manufactured into the outer casing by a global company called Jabil Incorporated, one of Apple's major manufacturing partners. The aluminum casing is produced in one of several of Jabil's factories spanning China, Taiwan, and the United States, among other countries. These factories perform the casting, machining, and finishing on the outer casing to get it ready for final assembly. The wireless charging coil on the back of the iPhone X is what allows the phone to charge wirelessly. The coil is made up of a series of copper wires that are wound together and wrapped around a small magnetic core. A similar coil on the charging pad emits electromagnetic field when current passes through, transferring power to the iPhone's coils completely wirelessly. The raw copper used to produce the wireless charging coil in the iPhone X comes from a variety of regions and mining companies around the world. Some of the major copper-producing regions include Chile, Peru, United States, and Australia, among others. Apple gets raw copper from a collection of many suppliers. In Chile, one of the largest copper-producing countries in the world, the copper mining industry is dominated by companies such as Codelco, BHP, and Anglo American. These companies extract copper from large open-pit mines where the copper is embedded in rock formations. The copper ore is extracted using heavy machinery and then processed using a variety of techniques, including crushing, grinding, and flotation to separate the copper from the surrounding rock. Once the copper is extracted from the mines, it is transported to processing facilities where it is further refined and processed to produce the high-purity copper required for the wireless charging coil in the iPhone X. The refined copper is sent to manufacturers such as Jabil, where it is used to produce the wireless charging coils and other electronic components of Apple's products. The lithium-ion battery is what powers the iPhone X. It is made up of a series of lithium-ion cells that are rolled up together into a compact rectangle. We could see here that unrolling the battery reveals the sequential lithium-ion cells. The battery is designed to be small and lightweight while still providing enough power to run the phone for several hours. The majority of the world's lithium is currently sourced from what is called the Lithium Triangle, which encompasses parts of Argentina, Bolivia, and Chile in South America. This region is home to some of the world's largest and highest grade lithium reserves and has become a major source of raw lithium for many companies, including Apple. Apple works with several suppliers to source their lithium, including Albemarle, SQM, and Livent, among others. Once a suitable deposit has been identified, miners drill a series of boreholes in the ground to extract samples of lithium-rich brine. The brine is then pumped to the surface and concentrated through a series of evaporation ponds, which allows the lithium to be separated from other minerals and impurities. Once the lithium has been concentrated, it is further processed to remove any remaining impurities and produce high-quality lithium product. This product is then sold to companies like Apple, who use it to manufacture lithium-ion batteries for their devices. Overall, the process of mining lithium can be complex and environmentally challenging, as it often involves the use of large amounts of water and energy. The refined lithium is manufactured into lithium-ion batteries by predominantly 3 manufacturing companies: LG Chem, Samsung SDI, and Panasonic. LG Chem and Samsung SDI are both based out of South Korea, while Panasonic is based out of Japan. All 3 manufacturing companies have factories across many countries, including China and the United States, where these ion batteries are created.